Hello guys, we are in Advanced Math Trig Mod 7. Today is Tuesday, April 21st, 2020. We're going to continue on with our exponential logarithmic explanations and progress through this log chapter. So taking your notes, top left corner, again, it's Tuesday, 4/21/20 for the date. Title of today's notes, logarithms, so just put logs, and then write down the two words expand and condense. We're going to take a logarithmic situation and expand it, or kind of tear it apart and break it down into its most amount of pieces possible, and then we're going to work backwards, take a longer logarithmic situation or equation and try to condense it and put the pieces back together. So the title is Logs, Expand, and Condense. And to do this situation or this type of problem, we're going to have to know our three basic logarithm rules. Now, I don't know who you had for Algebra 2 last year. This should have been introduced to you. I'm not sure how much detail or it was gone into depth with, or how much time was spent on it. But these three rules that I've got stars by are critical. Yes, they must be memorized. And by that, I simply mean be familiar with how the rule actually works and plays out in a logarithm problem. Product rule, a quotient rule, and a power rule. So first thing on our notes, put a star on your paper, highlight this, write the words product rule. And if you took any pre-calculus or even Algebra 2 book out right now, and they went to the logarithmic rules that are listed in that book, or on a formula sheet, so to speak, the first one is the log of, now notice it doesn't matter what the base is. That could be a base 2, a base 3, a base 10, could be an ln. Any logarithm that's the log of a product, m times n. Guess how you rewrite that, or can rewrite that if it's to your advantage in solving a problem. The log of m times n would be the log of m plus the log of n. So the product rule says the log of a product, m times n, can be changed into the sum of the two logs. So the log of m times n equals the log of m plus the log of n. So, simple little example, just to highlight that rule. If I saw in my paper the log of 5w, obviously there's a dot connection between the 5 and the w. Since it's the log of a product and there's a times sign, the times sign changes this into the sum, or a plus sign, of two logs. So I would, of course, write the log of 5 plus the log of w. Just a simple example of what the product rule entails. Okay? Well, the quotient rule. Obviously, product was a times sign. Quotient is a division sign. If you had to make a prediction here, on a product problem, we turned it into a plus. So I'm betting on a division problem, right, with a fraction bar, we're probably going to turn it into a minus. Agreed? So the log of m over n, the log of m divided by n, when I've got a quotient, I can change that into the log of m minus the log of n. Okay? So my simple example, if I have the log base 8 of 7 over x, and it's a quotient, I can change that to the log base 8 of 7 minus the log base 8 of x. Okay? And then finally, the third rule we've got to get familiar with when condensing and expanding logarithms is the power rule. What if I ever have a log problem? Again, it doesn't matter what the base is. And it's the log of something raised to a power. So the log of m raised to the p power. Okay, if I see that, guess what? You're allowed to take that power every time. Take the power and move it to the front of the word log. Okay, so the log of m raised to the p power, if I move that power to the front, would be p times the log of m. And that's our power rule. So, as a simple example, what if I had log base 3 of 5 to the 4th power? Oh, as soon as I see a power on a logarithm problem, it can get moved to the front, and I would write 4 times the log base 3 of 5. And those are the 3 rules we're going to get familiar with and learn how to work by expanding and condensing. That's the whole point of today's problems, okay? So the first thing we're going to do, last thing on the front of my paper, you go ahead and write expand each. And just to make sure we're familiar with and really know the 3 rules we just went over, I'm going to take these 4 problems and I'm going to expand them. It's like taking in a car engine and taking it apart and spreading the pieces all over the floor after you've expanded it and taken it apart and separated all the pieces. Now, what do I mean by that? Well, here we go. I've got an ln, that's a natural log, so that's fine. Any kind of logarithm these rules apply to. I've got the log of y times radical x, agreed? Stay with me, think with me, don't just copy here, because you're going to have to try to do this on your own here for an assignment tonight. Ready? Isn't that the log of a product? Because I've got something y times something else called square root of x. So using the product rule, I would change this into ln of y plus the ln of radical x. Agreed? That's step 1, but you're not done yet. Oh, because watch. Remember, you're trying to take this engine apart into as many pieces as you can. Do you guys agree that a square root box, I know I mentioned this yesterday, is really what? A power of 1/2, isn't it? So this is really ln of y plus the ln of x to the 1/2 power, because again, a square root box is really a 1/2 power. And now using the power rule that we just learned, I can take that power and put it in front of that ln. So technically, when I take this engine apart into as many pieces as I can, I'm expanding it. I get ln of y plus 1/2 ln of x. And that's what I expect to see as your circled final answer for expanding that logarithm. Okay? All right, number 2, log of a squared times radical a minus 1. I again see a dot connection. So I'm again thinking I'm going to take this product and the log of m times n is going to get switched to the log of m plus the log of n. Agreed? So I've got the log of a squared plus the log of... Now, once again, might as well learn from what we just did. Isn't that a square root box? So that's really a minus 1 to the what? Since it's a square root box, the 1/2 power. So going one step further on both pieces now, you agree this first exponent can get moved in front of that log, and this exponent can get moved in front of that log. So my final step in terms of expanding this problem would be to put the powers out in front, and I get 2 log a plus 1/2 log a minus 1. And I've expanded that logarithm. I'm just practicing using the important rules we listed up top. Third one. Okay, now careful here. There is a cube root box over top of this entire quantity. So the first step in my expansion, if a square root box is a 1/2 power, right? A cube root box is a what? A power of 1/3. So this is really ln of x over y squared, that whole thing raised to the 1/3 power, agreed? And now that 1/3, since it is a power, can get moved out in front of the log. So it's going to be 1/3 ln of x over y squared. So far, so good. Now I'm going to ignore that 1/3 for a second. Pretend it's not even there. This is m over n. Isn't that a quotient? So I'm going to think, let's do the quotient rule now. So I still have a 1/3 out in front of what I'm about to do now to the log of m over n, which of course is the log of m minus, now guys watch this, the log of, and then I'd put y squared, but do you agree that that squared is going to go in front anyway? And I'll put it out here. I just saved myself a step. Okay? Again, all I did, I saw the ln of m over n, right, a quotient, and I made it ln of the top minus ln of the bottom. But since the bottom is y squared, I put the 2 out in front. And to finish that problem up, do you agree that the 1/3 can get distributed to each? Because remember, I'm trying to go as far as I can, expanding this situation. My final answer would be 1/3 ln x minus, and then distribute 2/3, right? Because if I take 1/3 times 2, I get 2/3 ln of y. And that's what they expect to see for the expansion of that logarithm. And then finally, the last one on the front of my paper. Oh boy. Okay, even though you see a dot connection, you do not say product rule yet. You agree that's a fraction bar? So my first thought is this is the log of m over n. Oh, so using the quotient rule, I've got the log of radical xy to the 4th minus the log of z to the 6th. Now notice there was a base of w attached to that. I should still have that base kind of attached to the word log. So the log of m over n, I made the log of m minus the log of n. Now do you agree that right here, look where I'm pointing, there's a dot connection. So looking at this first log only, isn't that the log of m times n? So I'm going to turn the times into a plus sign. Agreed? So it's the log of w. Now, isn't that radical x really x to the 1/2? Agreed? Radical x is x to the 1/2. So I'm going to move the 1/2 in front and just have an x there. I just saved ourselves a time by doing 2 steps at once. Plus, and then we've got log w of y to the 4th. Well, that 4 will go in front of the word log, won't it? So it'll be 4 log base w of y. Again, all I did there was write log base w of y to the 4th, and the 4 went out in front. Again, saving time. Minus, and then here the 6 will go in front of that log. So it's 6 log base w of z. And I've successfully, wow, expanded that logarithm. It gets you to know your rules. Now, last thing we're going to do, I'm going to flip to the back. We're going to condense each. Oh, so now I've got a logarithm problem that's already been expanded. We're going to put the pieces back together, and I'm asking you, what did the original problem look like if this is the expanded version? So we're going backwards. Now, don't panic. Watch, this is actually easier than what we just did. Watch. Hey, guys, looking at problem number 1 here, log base 4 of w minus 2 log base 4 of y. You agree if there's an exponent, it was always supposed to get moved to the front. So if I see a number dot connected to the word log, I know darn well that that must have been a power attached to this letter. Agreed? So trying to put the pieces back together here, I've got log base 4 of w minus log base 4 of y to the 2nd. And because there's a minus sign, I'm going to change this back into a what? A quotient, right? Remember the log of m over n was the log of m minus the log of n? So this is the log of m minus the log of n. I'm going to change it back to the log base 4 of w over y to the 2nd. And I did it. Okay, I put the car engine back together and ended up with that condensed version of that problem. Okay, let's try the next one. Now this one, I think there's only 2 things to do. Once again, I see a number dot connected in front of the word log. Agreed? So if it's out in front, it must have been an exponent. So this is really an exponent. So this is log base 3 of 7x to the 1/3 power. But remember, a 1/3 power is really a what? A cube root box, isn't it? So do you agree this would be log base 3 of the cube root of 7x? And I'm done. Okay, don't make this difficult. Come down to the next one. What stands out? You got to look and think. You got to think on these. It's not just going to come to you like, like a robot or something. You've got to think about what's going on. I look at this and I see a 3 out in front of that ln. So I'm going to move that up where it belongs as an exponent. So ignore everything else and just kind of take care of one thing at a time here. We've got ln of x plus the ln of x plus 1 to the 3rd. And now that I moved the power out in front, I can worry about this plus sign. What was the product rule? Remember, the log of m times n equaled the log of m plus the log of n. I have the log of m plus the log of n. So I'm going to change it into a product and write what? ln of x times x plus 1 to the 3rd. And that's my condensed version. Finally, do we agree here on this first one? I'm trying to condense all of this. Guys, I can distribute that 1/3, can't I? 1/3 gets distributed to him and to him. So I'm going to have 1/3 ln y plus, what's 1/3 times 2? 2/3 ln of y plus 4. Minus, by the way, I still got that guy down there at the end that I'm not worried about yet. Okay, I've got a number out in front, dot connected to a log, so it must really be an exponent, right? This 2/3 must really be an exponent. So I've got ln of, now, instead of writing y to the 1/3 power, you know that's going to be what? The cube root of y, agreed? Plus the ln of y plus 4 to the 2/3 power. You can just leave that like that. Minus the ln of y minus 1. Okay, going to my last step here, or maybe next to last step. That's a plus sign. Agreed? So I got the log of m plus the log of n. The product rule says a dot connection turns into a plus. So if I'm working backwards, this is really the ln of cube root of y times y plus 4 to the 2/3, right? Then it's minus ln of y minus 1. And finally, now that that's dot connected, and I see a minus sign, the log of m over n always became the log of m minus the log. So when I see a minus, I'm going to turn it into a quotient. My final answer in condensing that situation, I've got ln, and on top I've got the cube root of y times y plus 4 to the 2/3 over, because of the minus sign, this is going to be underneath, y minus 1. And it ends up being that engine put back together, okay? All right, guys, even though that seems like what's the point is you've got to learn how to expand and condense logarithmic situations or expressions, or you're never going to solve the exponential and logarithmic equations that we're going to spend the next 4 days on. So these rules are important, and to learn them, you're going to try 4 expansion problems and 4 condensed problems on your own. Now, just so you can see them and take your time getting them copied and working on them, guys, if you look on your Schoology, right underneath this lesson that you just watched, there's an attachment also on Schoology that says 4/21/20 worksheet or 4/21/20 homework. Okay, and it's a separate attachment right underneath this one on your list of things in Schoology that you can go ahead and click on and look at, or even print it out if you want so you have a paper copy of it. But your homework is going to be an attachment that kind of looks like this, that has all 8 of your problems already written on it for you, okay? There will be 4 expansions and there will be 4 condensing problems. That, again, is a separate attachment or worksheet on your Schoology. Go to it, find it, click it so you can copy them or print it out with your printer. And your 8 problems that are going to be due tomorrow on Wednesday the 22nd. That doesn't mean these are due this weekend at your convenience. Guys, you're in school. You need to keep up with the 20-minute video each day. Big deal. And turn the assignment in as due, which is tomorrow at noon on Wednesday the 22nd, okay? Great job. Thanks for hanging in there. Give this a shot. And then things are much more mechanical and straightforward the next few days, the rest of the week, okay? But give this a shot and try to learn your rules. See ya.